In this lesson, we're going to continue to look at how to factor polynomials, and we're going to use a specific method called difference of squares. We're going to start the lesson by reviewing how you can check your answers. And so in order to do that, we need to look at how we're multiplying our monomials and binomials, and then we're going to move into actually factoring using difference of squares. So our last example from the previous video, we had to check our answers once we factored. And the way we did this, or the way I did it and showed you, was I used a distributive property. And that's an effective way when you're multiplying a monomial, in this case 3y cubed, times a trinomial. But there are going to be some times where you're not multiplying a binomial. You can't just use the distributive property. What if you have a binomial and you have to multiply it by another binomial? So like this example that you see in front of you, x plus 2 times x minus 2. Each of these terms is a binomial, so they each have two terms. So how would you go about checking your answers then? Well, there's two methods. One of them is called FOIL, and the other one is using a table method. And I'm going to be using throughout this module both methods, but I'm going to, in this lesson, explain how each one works. So first up, FOIL. In FOIL, we're going to look at each individual term, x times x, and multiply it. X times negative 2, 2 times x, and 2 times negative 2. For the table method, we're going to write a table, which is a rectangle, and then we're going to divide it in two, vertically and horizontally, like you see here. And then we're going to put each term of the binomial to have a column and a row. So then we multiply, much like you would a multiplication chart, x times x, 2 times x, x times negative 2, and 2 times negative 2. I want to illustrate that no matter what method you use, you're going to get the exact same answer, or you should anyway. So this is also a way for you to check if you're not trusting yourself just yet on using either method. You can do both and see if you get the same answer. After we do the multiplication, we're always going to combine our like terms. So once you decide I'm going to go with FOIL or table or both, go ahead and distribute, combine your like terms. So in this case, we have a negative 2x and a positive 2x that are like terms because the x is raised to the same exponent, which is 1. So after we do that, we get a 0, and our final answer is x minus 4. Let me go back and actually spell out FOIL for you and go over it again. FOIL stands for firsts, outsides, insides, and lasts. So let's take another shot at it. Most people get the table method really quickly, but have a hard time with the FOIL method. So let me go ahead and try it again with you. We have a binomial x plus 3, x minus 3. Let's take our first terms, x times x, our outside terms, which is x and the negative 3, multiply them together, get a negative 3x. Our inside terms, which are 3 and x, let's multiply those, you get 3x. And then last terms, which are 3 and negative 3. In that case, we'll get a negative 9. After we do that, we're going to combine our like terms. In this case, I only have a negative 3x and a positive 3x that are like. When we do that math, we get a 0, so our final answer is x squared minus 9. Now, I want to bring the problem that we did before we did this one, which was x plus 2, x minus 2. And our answer that we had was x squared minus 4. And I want you to see some similarities between the x plus 3 minus 3 and x plus 2 minus 2. Do you see some similarities between these two and the answers that we got when we multiplied them? What you should notice is that the number that we ended up with was actually a square of the factors of these numbers, because these numbers are the same, 3 and 3. Then our last number was a 9. And so there is a difference of sign. You're going to get a negative 9, and then you're going to get a negative 4 for the second problem. But you're basically going to get the perfect square of these factors. And so that is what we called a difference of squares. So whenever you see a binomial that's like this, for example, t squared minus 25, and they ask you to factor it, instead of like thinking of a different method on how to factor, the best way to factor this type of binomial is by using the difference of squares. So we know that 5 and 5 are going to give me 25 when multiplied. So I can just simply write my two binomials by writing t plus and t minus, and then putting the factors that together will make 25, in this case a 5 and a 5. So that is what we called factoring using the difference of squares. Now let's go ahead and do some other problems. I'm going to write some problems here, and then what I'd like for you to do is work them out. In the next video when I come back, I'm going to show you how to do them